Hey guys, so we're doing homework number 4, problem number 1, where we're given x is greater than or equal to 0 and the expected value is equal to eta. And if we have that, we want to show that the probability of x is greater than or equal to the square root of eta is less than or equal to the square root of eta. Okay, so we're going to start off with the expected value equaling to f of x dx from negative infinity to infinity. Remember, we're only working with positive values, so we're going to get rid of all the from zero. We're only working with positive values and zero, so we're going to get rid of all the negative values. But you know for sure this is true because when you tighten the bounds in an integral, it's like on a graph. If you kind of shift the bound towards 0, you lose all your negative, you lose all the area you have on the negative side of x. And so that's why this area has to be greater than this area. And we're going to follow a similar theme, okay? Okay, we have right here, we're going to tighten the bounds, okay? Instead of 0, we put a value that is not 0, but that you know is positive. And so when you move it from 0 to a more positive bound, you have essentially a value that is less than or equal to this value, right? Does that make sense? Same thing with the theme last time. All right, we're sticking with the same integral right here. All right, so this integral is in the last sheet, okay? And then this time, instead of having x, we're going to change that to the root of eta. The root of eta, so eta is to the 1/2, x is to the 1. 1 is greater than 1/2. The degree here, 1 is greater than the degree here, 1/2. That's why this has to be smaller than or equal to that. All right, and then we're going to work with that last integral right here. We pull out the eta, the root of eta, and we take the integral from the root of eta to infinity of f of x dx. And essentially, this is what we get. We get the root of eta times the probability mass function right here, which signifies big f of x is greater than or equal to the root of eta is less than or equal to eta. And the reason why we can do that is because this is your probability density function. When you take the integral of a probability density function, you get the probability mass function. So, and when you just divide both sides by the root of eta, this is what you get. Therefore, basically, back to square one, big f of x is a big f of x is greater than or equal to the root of eta is less than or equal to eta, because eta over the root of eta is eta. Okay, so that's how you do problem number 1. Thank you.